So on that one, I would start multiplying by the denominators that I need to get rid of, which in this case is actually just that x plus 1. And I would multiply it times each term on the top as well as on the bottom. Remember that for complex fractions, we tend to not multiply the bottom together to keep things a little bit cleaner in hopes that something will cancel out. So here I would cancel out the x plus 1 there, which would give me 2x. Here I would just have to be careful because nothing's going to cancel with that, but you're going to have to distribute a -1, which makes it -x minus 1. I'm going to leave the bottom unfoiled. And combining like terms on the top then gives me 2x minus x is x minus 1. Just like we hoped, we can cancel out that factor of x minus 1, which leaves me the simplified version of 1 over x plus 1. Go back, plug in 1 now. 1 over 1 plus 1 gives me a limit of 1/2. Anything else on this page we were unsure of?
Question. So on number 1, when I tried to like factor it out normally,
Yep.
Doing like trial and error,
Yep.
either I made a mistake or I couldn't figure it out, or like it didn't work that way.
You
Does
didn't
it work?
do anything other than plug it in on 1.
Okay, so I should plug it in first before trying to factor.
Definitely, especially if something's not a fraction. I don't tend to anticipate problems unless it's a fraction right now.
Okay.
So if it's something that doesn't have a bottom or a denominator to it, just plug it in, see what you get.
Okay.
Okay. Other questions on this page? All right. Second page. Limits algebraically with this lovely piecewise at the end. Nothing? Ooh, not too many questions. I like that. Means we are doing well. All right. If no questions, I will then keep moving and we will talk about limits algebraically a little bit more with trig limits. I'm not going to spend a lot of time reviewing because we had a lot of homework on that and it seems like we did well. So we'll just kind of fly through the beginning stuff and then add in trig limits to this. So thinking back to what we did last class, we're on page 295 in your notebooks. What we did last class, we talked about kind of that flow chart idea where you always try to plug it in first and then we have 3 methods: factoring, multiply by the conjugate, or simplify the complex fractions. If one of those 3 doesn't work, we then tried to check a graph on our calculator. We're going to add kind of in that same category 1 additional method, which is going to be simplifying your trig limits on this one. Before I start talking about that, let me stop sharing for just a second and show you in your Canvas, because this is one of those times that I did not do everything in advance in the notebook that I should have. So, yes. Your homework for today, if you looked through this page at all, is not there. So I've uploaded it like 3 places in hopes of getting everyone your homework. We are on lesson 9.3 right now, limits algebraically, day 2. So this kind of title page where I have the due dates and stuff, there's one place right here where it's linked. I think if you go to the next page, let me try that real quick. That's the video, I don't have it there. I think I also put it under the homework assignment itself. It is also on my PCA on the grade book or the assignments for today. Let's see, where's my assignment center? So for homework 9.3, if you find that, because it's due next week, and you look at that, I also put the download under that. So all the places to find the homework, lots of places we can find that. So real quick, we are going to go back to our notebooks. If I can figure out where I'm going with that. Oops. Oh yeah. All right, so what we talked about last class was, just a quick review. You always try direct substitution first. I'll plug it in. Substitution. If that doesn't work, we can try factoring. We can try to multiply by the conjugate. And we can try simplifying the complex fraction. And if that doesn't work, we always check the graph. So that's kind of like try one first, then try one of those three methods, and then if that doesn't work, check the graph on that. After that, we're going to talk about adding in trig limits kind of in this set of three. If it involves trig, we are always going to do direct substitution first, so that doesn't change. If you can plug in whatever the limit you are finding, go for it, do it. If you have problems, then we are going to simplify trig functions. Okay, so just like we did in proofs and in solving, we will simplify the trig functions as much as we can. So for example, if there's a tangent in there, you can replace tangent with sine over cosine and stuff like that. Now, there are two boxes directly below this that we're going to talk about briefly. These are called special trig limits, and these will have to be, well, usually I say they have to be memorized, but that is typically when we are in school. Since we are not in school, we are just going to have them clearly as notes here, and then we'll use them. So the two special trig limits are limit as x approaches 0 of sine x over x equals 1. These are very specific, so it has to be the limit as x approaches 0, and it has to be sine x over x. We're going to talk about a different way to manipulate that right there today. There's one additional one that involves cosine. Limit as x approaches 0 of 1 minus cosine over x is equal to 0 all the time. So go ahead and write those down real quick before I admit our other people, and then we'll talk a couple review questions and trig. We all have that? All right, here we go. All right, so just review questions that we've done already, but we'll go through them really quickly. In a case like this one right here is a great example, this top left one, of that not all fractions are bad. Like I tend to immediately, as soon as I see a fraction, start like factoring and trying to cancel stuff out. Is there any problem with plugging in 1 in this one right here?
No.
Plug 1 directly in, that's going to give me 1 on the bottom of a fraction. Totally fine. So just don't like jump to conclusions on that. There will be places that you just plug in your number. That's totally fine. Now, if I use the exact same question to the right, but x is approaching 0, suddenly that's a problem because you can't have 0 on the bottom. So I would go ahead and simplify this by factoring out an x, which allows us to cancel out the x on the bottom. Now I can do the limit as x approaches 0 of my simplified version x plus 2. Plugging in 0 gives me 2. Super easy, yes? All right, another method we talked about last class, just review, is multiplying by the conjugate. So help me remember on this one, what would I multiply top and bottom by in this third question here?
Radical x plus 5 plus radical 5?
And that is the key to this one, where you change the sign. It's never inside any of the radicals. It's always the sign in between the two terms. Okay, so I change that minus sign to a plus sign. Remember that the rule of thumb is that you will not multiply out the bottom, or the one that is not the conjugate, I should say. It's not always the bottom. And you will FOIL out the top there. what is going to be root x plus 5 times root x plus 5?
X plus 5.
X plus 5, because the rule is it just cancels out the radicals, right? I don't really care about the outer and the inner terms because by multiplying by the conjugate, it's going to be a positive version and a negative version of the same thing. So then I'm going to skip to negative root 5 times positive root 5 is negative 5. I can then continue to simplify. 5 minus 5 will cancel, which then allows me to cancel what?
The x.
The x. So I am now going to find the limit as x approaches 0 of 1 over root x plus 5 plus root 5. Notice just notation right there. I haven't plugged in anything. The only time you can drop your limit notation is once you plug in the number. Okay, so now I can drop the limit notation. What's root 5 plus root 5?
2 root 5.
Mm-hmm. And we can leave our answer there. We don't have to simplify the radical on that. We can just leave it. All right, quick other reviews here. And then you see underneath the first two here, we're gonna hit trig. So that's where we're gonna see that. All right, so on the first one, we have a complex fraction. Can't plug in 0 top and bottom. So someone tell me, what am I multiplying by top and bottom here?
X plus 2 and 2.
X plus 2 as well as 2. And I'm going to multiply that times both terms on top as well as bottom. So going through each of these one at a time. Top left, my x plus 2 is going to cancel, which will give me 2. Top right, the 2's are going to cancel, and I'm going to be careful distributing that negative 1, which will give me negative x minus 2. And on bottom, kind of our rule of thumb for these, we don't multiply that all out because we're hoping to cancel something. Let's work on the top here. The 2's will cancel, which will also then allow what else to cancel?
One of the x's?
Yep. This is just a 2 times an x plus 2. So I can still cancel an x right there. And it's going to leave me negative 1 over 2 times x plus 2. All right, so I have limit as x approaches 0 of that simplified function. Yes, okay. And now I can plug in 0. Drop my limit notation. Simply gives me negative 1 over 4.
Do we have to keep the limit notation up until that point?
Yep. You do have to keep the limit notation. So what I've done over here is kind of like side work. I don't know if my mouse actually shows up there or not. What I've done there is just kind of side work, simplifying the function. So when I go back to actually finding the limit, I will always write it one more time and then drop it once I plug in. It's not technically proper to drop it before you plug it in. Yeah, that's kind of the rule of thumb. So that the last algebraic one that we have right here before we do trig is just kind of one of those reminders of like, and you guys got used to this with proofs and solving. I threw all different symbols at you. Don't freak out about them. They're just all different symbols, and that's totally fine. The key on this one, though, to remember is what you're finding the limit as this is approaching. So like in this particular question, you have delta x approaching 0, which means I am not going to plug in 0 for x itself, which may mean that I have an answer with an x in it. Totally fine. So let's just look at this as if it's a normal problem. Don't worry about the deltas on it and just handle it normally. If I currently plugged in 0 for delta x, would that be okay? No, because there'd be a 0 on the bottom, right? So any ideas as to what I could do first on this to figure out what this is going to look like?
Multiply the squared function.
So I'm going to kind of multiply out the whole top of this here. I'm going to square x plus delta x, which literally means foiling the whole thing. So for those of you that are prone to forget that, don't forget that that's literally doing x plus delta x times x plus delta x. Okay, so let's kind of multiply that all out and see what we get. If I FOIL that out, that's going to give me x squared. X times delta x and x times delta x is 2x delta x. And delta x times delta x is delta x squared. And then I would distribute my 3. So I've got 3x squared plus 6x delta x plus 3 delta x squared. And then I still have this minus 3x squared from the end. Anyone see something that's going to happen here for us? What will
Can
simplify?
the delta x cancel?
I can't yet because not every term has one in it, but check out these on the top. What's going to happen to those?
Ah, the 3x squared go away.
My 3x squareds go away, which is kind of nice for me because it gets rid of the terms that have no delta x in them. Now what can I do on the top? In order to cancel a delta x, I have to factor 1 out at least. So you could factor more than just delta x out of the top, but I can factor at least a delta x. I don't really need to factor more than that. So if I take a delta x out of this term, what is left in that term?
6x.
6x. And if I factor a delta x out of that term right there, what's going to be left?
3 delta x.
3 delta x. Now, what does that do for me right now? Allows me to do what?
Cancel out the delta x on the bottom.
All right, so now this is my simplified version. Let's go back to the beginning. I'm going to find the limit as delta x approaches 0 of now, 6x, excuse me, plus 3 delta x. If I am finding the limit as delta x approaches 0, what am I plugging in 0 for?
Delta x.
Delta x. So I get 6x plus 3 times 0. So what is my official answer to this limit?
6x.
You may have an x in your answer because x is not what you're finding the limit of. You are finding the limit as delta x approaches something, not x approaching something. So you may have an x in the problem or the final answer. You should not have a delta x in the problem. Okay. So that's kind of like a different look at one of those. As you get into calculus, you're going to see more things with delta x's. Some of your homework had h's in them. So you're just going to see more and more of the different notation there just to kind of get you used to some of it. Okay. All right, let's talk trig limits real quick. For those that jumped in after, we said another method kind of with the factoring, multiplying by conjugates, simplify fractions was to evaluate trig limits. So with trig limits, we said that we can always do direct substitution first. In other words, plug it in if you can. After that, if that doesn't work, you can simplify trig functions. And that's like substituting for tangent and stuff like that that we've already done. We did talk about 2 special trig limits. The limit as x approaches 0 of sine x over x is equal to 1. The limit as x approaches 0 of 1 minus cosine x over x is equal to 0. So those 2 special trig limits, you're going to kind of want to watch out for. See if you can figure out how to manipulate a trig function into that, if at all possible. So I went back to that because on our trig things down here, we're going to start talking about that. All right, so first off, take a look at this left one here. Limit as x approaches 0 of sine x over 4x. First off, mental thought, can I plug in 0? No, because it gives me what on the bottom?
0.
0.
Never a good thing. Still not a good thing with trig. So my next thought is see how I can manipulate it. This, hopefully, considering we just talked about it, should look a little bit like one of our special trig limits. Which one?
The sine one.
Sine one, right? Now, we should be a little bit hesitant about that because is it exactly that?
No.
No, it is not. I got a 4 in the bottom, right? So here's how you're going to think about some of these. There's a 4 in the bottom of this one. What's technically in front of the sign?
A 1.
A 1. Now, I'm going to show this the first time. I'm not going to ask you to show this kind of work every single time. This is essentially saying the limit as x approaches 0 of a constant 1/4 times sine x over x. Now, something that we've not talked about with limits is that if you have two limits that are multiplied together, you can essentially separate them. So this is mentally what you're doing. But like I said, you're never going to do this again. I'm just going to show you this time. This is essentially the limit as x approaches 0 of 1/4 times the limit as x approaches 0 of sine x over x. All right? Now, here, is there anywhere to plug in 0?
No.
No, because there's no x, right? So that limit is just 1/4. What did we say this is according to our special trig limits? The limit as x approaches 0 of sine x over x is always what?
1.
So my answer to this entire problem is 1/4. Okay? But like I said, I don't want you to show those steps every time. What I want you to be able to do is back here, identify there's a 1/4 right there. So that's going to be the 1/4 times the 1 from the sine x over x. Done. 1/4. But I show you how to manipulate that the first time. All right. Any issues or questions about how we're kind of manipulating our special trig limits? All right, so take a look at the one next to it. Again, looks similar to one of our special trig limits, but not exactly like it. This time it's the cosine one, right? So in this case, what we're kind of separating is that there's a 7 right there out front, 7 over 1. Okay, so this is essentially the limit as theta approaches 0 of 7 times our special trig limit, 1 minus cosine theta over theta. Well, what was this limit according to our special trig limits? That is equal to what?
0.
0. This limit would be 7. 7 times 0 is still going to be
0.
0. So a lot of these can be manipulated into different versions of those special trig limits, which is why they are going to be they're going to be pretty important to us.
Could we have just said that 0 at the beginning?
I couldn't really hear that. What was that?
I was gonna ask, like, can't we just say it's anything you multiply by 0 is gonna be 0? So why can't we say 0 at the beginning of the problem if we
You
see?
can.
Okay.
Yeah, I was just showing you why 7 went away. You don't really have to worry about it as long as you can get that. It's good. I kind of show additional steps here and there. But someone remind me, there is one like this first one on your homework that I want to talk about before we leave for today. So don't let me forget. This next one on the bottom left here, it's also going to be manipulation. This is going to bring you back a little bit to proofs and solving and all of that good stuff. Because does this look like either of our special trig limits right now? I mean, it looks to me, the first thing that I see on this is that it kind of looks like a combination of like parts of them. But I also recognize, can I plug in 0 right now? No, because I'm going to get 0 on the bottom. So think about this like you did with proofs and solving. What could you do to like work on this and make things change?
You can do difference of squares on the top.
You could do difference of squares on the top. That's one way to go about it, which is separating it into two different things. And actually, I kind of want to show you two different ways, if you don't mind. So the immediate one here is to do difference of squares on the top. That's 1 minus cosine x and 1 plus cosine x. I like this, and that's immediately how I kind of would have approached it, except for the fact that it's kind of keeping you stuck in one spot. One of our special trig limits is this guy, 1 minus cosine x over x. And so that's going to turn into 0. But the problem is that still, if you plug in 0 to the second part, you're going to get 0 on the bottom. And there's really no way to manipulate this. So you might kind of try something and get stuck and then maybe back up a step again. Does anyone see another way we could have started that without doing difference of squares?
You can replace the top with sine x, sine squared x.
Yep, so you can do sine squared x in place of 1 minus cosine squared x. So remembering our old trig identities can really help. Well, what does that do for me on this one? I can now do what?
Cancel out the
Cancel out one sign on top and one sign on bottom. So now I'm doing the limit as x approaches 0 of sine x over x. That should look familiar to us. That is a special trig limit. What does that equal to automatically?
1.
1. Good. So a lot of these with some very basic trig manipulation will turn into something really, really easy. Okay. Any issues, problems with that? Before we move on, I want to show you a different one here. And it kind of looks like the first one we did with the sine, and it kind of looks a little different. All right, if I gave you that, does that kind of look like our special trig limit for sine? Yes.
Yes.
Yeah. What's the difference?
The 4x.
The 4x. Now, hopefully, crossing my fingers, I get the right answer here. We learned something when we were doing all of our identities for trig, and that is, what can you not do with that?
You can't like take it out.
Exactly. So that is very different than, let me just give you a second example, this. This is a 4 over a 1 in front of the sine x over x, so I could say that limit is 4 very easily. Right now, I can't do that exact same thing with what I have up here. Now, if you remember from when we did solving and when we did proofs, we looked at that, then we separated these into sine of 2x plus 2x, and we did a bunch of like addition formulas and all of that. The good news is that you do not have to do that here. And I'm going to show you why not. What I am going to do here is when I see a number on the inside of that, I'm going to multiply by a form of 1 on the outside. And it's going to be a very particular number, okay, 4, to match the number on the inside. Am I allowed to do what I just did?
Yes.
Yes, because it's multiplying by 1. Now, here is what we're going to see come from this. A manipulated version of this, our special trig limit equaling 1, is exactly what I have circled in purple over here. This, when we first learned this, we think of it as being very specific, sine x over x, and it always has to be that. But what we find out about it is that as long as the x matches top and bottom, it equals 1 every time. So these are all examples of the same thing. These are all, as long as the x matches top and bottom, it equals 1. Okay, so by multiplying by that 4 over 4, I forced my x's to match right here. That is therefore 1. That 4 that I multiplied by out front is what makes the answer to that question 4. It's not the 4 on the inside. So you're not ever going to be factoring out a 4 from the inside. You're going to be multiplying by the number out front. So that's another way to manipulate that trig identity in order to help you get an answer. But we talk about that very carefully because I don't want you to think that I'm pulling a 4 out, because that's not legal. Does that kind of make sense where that came from? Or do we want to see another example of that? Or, okay. All right. Then I have 2 more questions to do, and then I'm done. Promise. All right, so last 2 questions here. Limit tangent x over x and limit of sine squared x over 2x. First off, on the tangent x over x, if I'm finding the limit as x approaches 0, can't plug in 0. 0 on the bottom, bad news. So my next thing would be special trig limits. Well, definitely not right now because none of them involve tangent. So what's my first go-to for tangent?
Make it sine over cosine.
Make it sine over cosine over that x that was already there. Now my goal here is to kind of manipulate this a little bit to get to the point that it looks like one of my special trig limits, or I can plug in my limit the way it was. So when we have double fractions, which is what we have here, even if it's just an x, it's like an x over 1. The way I simplify these is keep the top one and I take the bottom one and flip and multiply. So what this is going to look like now, and some of you can do this in less steps, I'm just showing this for everyone, is going to be exactly like that. Okay. Now, why might this help me? Well, we talked about a little bit earlier that you can separate parts of limits, and that's helpful to me now because do you see the building blocks for one of our trig limits, special trig limits here?
Yeah.
Yeah, we see, hopefully, that. So what we're going to do is we're going to separate this. We're going to say this is the same as sine x over x times 1 over cosine. Okay? Well, essentially, and you don't have to write it this way, but we're doing 2 different limits multiplied together. We're doing the limit as x approaches 0 of sine x over x multiplied by the limit as x approaches 0 of 1 over cosine x. What did we say according to our special trig limits that whole thing right there is equal to?
1.
1. Now the second one, this isn't a special trig limit, but is there a problem with plugging in 0 for this one? What is the cosine at 0? Think chart.
1, right?
1, right? So 1 times 1 is equal to 1. And I can get an answer that way. There's not always going to be a problem with plugging in 0. Even if you are plugging in 0 to the bottom, especially because in trig, sometimes your trig values will work out nicely. And that's okay.
Why does sine over x equal 1 when it really, in reality, that would be saying 0 over 0?
Well, first off, it's just one of our special trig limits there. But here is why. Give me a second to pull up my graphing calculator and I'll show you why. Where is it? All right. While I'm pulling up my graphing calculator, let's take a look at the last one. Remember with trig limits that it's just the same as all the other ones. If you can plug it in, plug it in. Is there a problem with plugging pi into the bottom of this? No, right? Now the top, what's going to be the sign at pi?
0.
0. 0 on the top. Is 0 on the top okay? Okay, so what you're seeing on this last one real quick is that you can still plug stuff in. This one I really like. I just like it because it reminds us that 0 on the top is fine. As long as you don't get 0 on the bottom, you can still get 0 as an answer. Because we get so tense about 0 being on the bottom. We tend to forget 0 on the top is fine. So don't forget that. Sometimes we just plug it in. Now,
Why is 0? Why is
Why
the
what?
top 0?
Because sine at pi, if I think about my chart.
Oh yeah.
Okay. Now, that question of that special trig limit, let me show you on a graph. I got to share this, why that works. Okay. Ooh, calculators. Here we go. If I were to graph sine x over x, because you're right, that essentially is 0 over 0, right? Oh,
Mhm.
grief, what is happening to my thing here? Nothing is working. Sine x over x. The X button on my computer stopped working, right? Not a big fan of this. It's not doing well, and I don't have tech support to help me. If I graph sine x over x, and this is a good reason for why it works for that other manipulation that I showed you with the 4s. If you look at this graph, can we all see my graph?
Yes.
Okay, so even though you do sine x over x, you're getting 0 over 0. Remember that our kind of in our flow chart, we said plug it in, try one of our manipulations. If it doesn't work, go check your graph. This is a good example for when we tend to expect does not exist, but it doesn't always mean that. If I found the limit on the graph, can I make a prediction as we approach 0 in the middle here? What is it getting closer to? Yes. What we're seeing that what we don't see on the graph is that there's a hole in the graph right here at 0, but you can still find a limit. It's still approaching 1. And this is also the reason why it works, that if you make it 5x over 5x, still going to 1 in the middle. If it's 3x over 3x, as long as that number matches top and bottom, it's always going to be approaching 1 in the middle. So that's why that manipulation worked, that when I multiplied by the 4 over the 4. Does that kind of help on that?
Mhm.
Okay. And the 1 minus cosine x over x, that's the same thing. If you wanted to see why that one is, because it's the same thing. If you plug in, oh dear, don't do it. If you plug in your cosine, it's always going to give you, or your 0, it's always going to give you 0 over 0. If you do 1 minus cosine of x over x. Same reason there, because even though you have a hole in the graph at 0, it's still going to be approaching 0 in the middle there. All right, real quick, let me just show you homework. Let me pull that up for you so I can show you the homework. I showed you all where to find it. We all know where to find a version of the homework since I've uploaded it like 15 million places. Yes.
Yeah.
Okay, so, and again, I kind of apologize for that. The end of this year was a little bit in like, I'll figure out what we're going to do, and I'm figuring it out, but we're not there, so it's lots of fun. So there's a couple extra evaluating trig limits, just practice with factoring, complex fractions, all of that. This is great practice for your quiz, which is next class. And then there's some trig limit stuff here and piecewise function stuff as well. This is the big trig limit stuff. But here's the thing, guys. This is not supposed to take you, like I know that's like a million problems. It's not supposed to take you long because this is the 5x over x. So I would put a 5 in front of both of those, and that's going to be 5. Very similar on a lot of these. So you're just going to be plugging in a lot of things. This one, cosine at 0 is not 0, so you can plug in 0 top and bottom on this one. So a lot of them are going to be plugging it in. You should be running through those pretty quickly. So that's your homework on that, those pages. It's a 3-page document, but the first couple, not real difficult, so don't spend too much time on those. If you get stuck, let me know. Quiz is going to be next class. So last thing I'm going to show y'all, let me try to pull up my module setup. Oh, also, while I'm on with everyone, Did we all, the juniors, get your, the note about signing up for groups? Yes? Or no?
Yes.
Okay. That's totally optional. I'll kind of show you where to find that. People have asked, like, do you have to have a group? Absolutely not. What I'm trying to do here with the end of the year, I know we have AP testing and like this is getting old for everyone. Yes. So I'm just trying to give you a little leeway to finish up the year how you would like to. It's basically an open note, like 4 or 3-page test grade. There's 2 lessons, but I have them pre-recorded, so I'm not going to necessarily go live for Unit 10. What I'm going to do, am I showing my canvas here? Please tell me.
Yes.
Okay, good. So what I'm going to do under Unit 10 down here is basically build, here's the 2 lessons and the 2 homeworks that you need in order to do the test grade. And it's going to be open from the 12th to the 22nd. So whenever you and your other people feel like doing this, go ahead. It's going to give you some leeway to not have to have things due on AP testing days and other things that you have coming up for your other classes. So what it's going to be is everything is due by the 22nd, both homework assignments and like the test grade assignment. So if you want to do everything on the 12th and be done for the year, totally fine. If you want to wait till the 22nd and do it all, totally fine. Midnight will be your deadline. That will just be how I do it. So I have your quiz set up here for Monday. I figured out some fancy new things for our quiz. You're still going to have to show your work on stuff and upload that. So plan on that as you're taking your quiz. Some people.
Well, we have to do the step-by-step explanation thing.
Let me do a little research into what these are. I think a little harder for computer programs to help out with. So I don't know. Let me look at what I feel like I need to ask for based off of what Photomath gives me. Because I don't know if it's possible to type these in or not. I think it would be a little bit more difficult, but we shall see. I will let you know for sure. Right now I have it set up as yes, but and there's like the graph questions, you know, that you're just finding the limits off the graph. You don't have to explain those because there's literally no way for anyone to cheat on that, because if you can figure out how to plug that entire graph into Mathway and have it give you the answers, like props to you. I mean, come on. I don't know how to do that. So, because I did set up a whole question with that. So lots of fun. I spent like an hour and a half making this quiz, but it's going to work great. I've already tested it. So good time. Any questions for me before we sign off for the weekend?
Wait, so
It's going to be the same thing that we have been doing, where it's like you plug in your answers and then submit a picture at the end.
Yes. So the way I have it set up is like 10 questions again. The first question is the graph question. And I think I pretty clearly stated, like, you don't have to write down work for that, because that really should be looking at the graph and typing in a number. So what I'm going to be looking for is work from 2 through 10. And that is question 11 that you have to submit that. Okay.
so Unit 10 doesn't open until May 12th.
I have it set that way because our test is not till the 11th for B-Day from Unit 9. Would we want it open earlier?
I mean, I don't know.
If
It
anyone,
doesn't hurt, but I'm not going to do it earlier.
okay. Well, I may open it up because it's not like you really need what we're doing right now to do it. So it doesn't hurt me to open it early, honestly. So yeah, and for groups, let me just make sure y'all know how to get there. You should be able to access people over here on the left-hand side. So we have people, and then underneath that, you see everyone, and then there's Unit 10. So this is where I realized I had to set up like group templates for you guys to get into. It doesn't matter which one you sign up for. People just picked random ones and joined with their people. If you're going to be by yourself, you can go ahead and just pick a group and put your name in it so that I have that down. Obviously, seniors, You don't have to do this because that's Unit 10 and you're not with us. You're excused for everything from Unit 10. So you're just going to see an X in the grade book. If you want to work by yourself, just stick yourself in a group by yourself. If someone signs up with you that you don't want to be in there, send me a message and I'll stick them in somewhere else or remove them from your group. Because with self sign up, I can't like say you can't sign up for certain ones. So just let me know if you want to work individually, because I can manually take a group back down to one if you want to do that. So totally fine. You're more than welcome to work with one other person, 2 other people. Let me know. And if you can't find a group or want to work with someone, just let me know that too. I can help you figure it out. It's not like you have to have this now, but just that's where you do it if you need to. Okay. Anything else I can help you with as we keep moving here?
On the homework.
Yeah.
On number 8 or question H.
Yes.
Is it just undefined? Because when you multiply everything out and you subtract 8, you can't really go anything from there.
You should be able, because that's cubed. If, ooh, can you factor that? What did you do on H?
So I did all of my multiplication stuff and got to x cubed plus 9x squared plus 27x plus 27 minus 8.
Mhm.
Then you subtract 8 and that becomes 19.
Mm.
And then you can't do grouping because 19 is prime.
If you can't do anything else, always check the graph just to make sure.
Do we make a graph?
Well, I mean, just type it in your calculator.
Oh, okay. Because it says without calculator. So I was just like,
That I'm also kind of debating. You could factor the top as a difference of cubes without multiplying it out. This first term is cubed, and then this second term would be 2 cubed. Let me just see if that works. It could do something interesting. Just take a guess on this. If I factor that as a difference of cubes, it would be 3 plus x minus 2. And then the first one would be plus x squared plus 3 plus x times 2 plus 2 squared. I don't know if this is going to do anything, honestly, but so that first parentheses would work back to 1 plus x. I don't really see this doing anything, but let me look at that one because I haven't actually, this was something I would like made for homework the other day. Right now, I'm not 100% sure how to solve that one out, but let me look at that one. That's the only one that I'm.
here's the graph. I think there's an asymptote at 0.
Yeah, if there's an asymptote at 0, then it's going to be does not exist for sure. So there could be something in here with that too. Honestly, like anything I say, do not use a calculator. Understand we're talking open notes and stuff right now. So you could need to. All limits, your last thing is check a graph. So honestly, if you need to, do it.
Miss Lyon,